now that we have all the boilerplate set up, what we're going to want to do is set up the sprinting portion. So the first thing we want to do is think of how do we want to sprint from Blueprint. Well, in my case, I just want a simple function call through the character movement component that I can easily call. So I'll get the character move component, cast it to our custom one, then simply call a blueprint callable function and be done. So to set that up, we're going to do a blueprint function or a blueprint callable function. I'm going to give it a category of tutorial. Whoops. And then we'll just call it set sprinting. And we'll pass in true or false based on if we want to sprint. So bool sprint. So if sprint is true, we want to sprint. Otherwise, we don't. So let's go ahead and create the definition. I'm going to put it right below the constructor to keep all this stuff separate, keep it nice and clean. And now we want to have something that we can set sprint to. So in our case, we're going to be using a bit field. So uint8 b wants to sprint, and we'll assign it to 1. So this is going to be equal to sprint, like so. Next up, we want to modify update from compressed flags. So we need to add some stuff in here. So what we're going to do is set b wants to sprint to equal the first custom flag. So to do that, we set b wants to sprint to equal flags, and here we want to get our type. So f saved move character. And we want to get the custom flag 0. So flag underscore custom underscore 0. Now by default, basically when this is, let's say, on, so to speak, this will give us a value of 16. When it's off, it'll give us the value of 0. So we can simplify that, or not, let me rephrase that, set it to where it's just 0 and 1 by doing a brief comparison. So basically, if this does not equal 0, then it's a 1. Otherwise, it's a 0. So we want to check and make sure that the flag does not equal 0. So next up on the list, we have get prediction data client. So let's head over to that right here. So what we want to do is we want to get our client prediction data. And we also want to do a check. So if it does not exist, we want to create it. So what we return first is client prediction data. Then we want to do our check. So if client prediction data is invalid, we want to go ahead and actually set it up. So let's go ahead and first off, let's see, we're basically going through our own class. So it is constant. So we want to go through, create our own copy of this class. Kind of screwing up on the brain here. So basically going to be creating another constant of this class. So it's still going to be a pointer to this class. However, it's going to be one that we can assign stuff to, if that makes sense. I know there's actually a word for it. I just don't know what that word is. But basically, we have u sprint character movement component. Let's just call this one temp, I guess, is a temp component is an okay one. And basically we're going to do a const cast of the type u sprint character movement component as a pointer. And we're going to do that from our own class. Now I'm going to go ahead and do a wrapper. So if it is valid, just to make sure, then what we want to do is set temp component client prediction data to equal new f sprint network prediction data underscore client underscore character, fun name, and then our class. Right, got to dereference, like so. And that'll go ahead and set our client prediction data if it is not already. So this one is now good to go. So let's go ahead and move down the chain to clear. Well, better yet, everything inside of our f sprint saved move. So we want to do the exact same thing. However, we are also going to be doing, sorry, let me rephrase that. We're going to do the exact same thing that we have in our character movement component. However, we are going to be modifying its own kind of variable, so to speak. So it has its own saved move. Then that saved move gets applied to the character movement component, if that makes sense. So here we have B saved wants to sprint. And then when we do everything inside of clear, compress flag, set move, prep move, so on and so on, it's going to be on B saved wants to sprint. So heading over to clear, what we're going to do is just set it to equal false. Then next up, for get compressed flags, so if we actually look at what the parent class or the parent call is doing, we can see kind of the result, or literally result. But basically, what it's checking for is if the flag, so basically if they want to jump or if they want to crouch, is equal to their current flag. Well, this is a what's the bloody operator called? I think it's equal to itself or the flag. I'm not entirely sure. But anyways, you can basically, if you're confused at kind of any step of this, what you can oftentimes do is go through and just kind of get an idea of what the parent calls are doing. And that should give you the basic way of moving forward and continuing with it. So we're going to be following along, doing the same thing here. So if B wants to sprint, or B saved wants to sprint, then we set the result. So exact same thing. So let's go ahead and get the super. So uint8 result equals the super, and then we return the result. So if B saved wants to sprint, result, and we want to check the flag. So custom underscore, yep, there it is, flag underscore custom underscore 0. So this is kind of letting us know that B saved wants to sprint. We're good to go. So let's see. Let's move on to, is it set move 4? Yes, it is. So set move 4. So set move 4 and prep move 4, they're basically exact opposite of each other. So basically what we're going to be doing in here is getting our character, getting the custom movement component from it, and then assigning our B saved wants to sprint based upon the character movement components B wants to sprint. And then the opposite for prep move 4. So we want to do a check. So if C, which is our character, as you can obviously see from the parameter here we want to get the character movement component. However, we want to guest it to our custom character movement component, which is going to be our sprint character movement component. So if U sprint character movement component, let's just call it move component or movement component equals cast U sprint character movement component from C, get movement component. What we want to do is set B saved wants to sprint equal to movement component B wants to sprint. Now you're probably going to have to include, I know it auto included, I don't know if that'll be the case, game framework character.h, but I'm not entirely sure if you're going to have to. That's just what Rider auto included for me. Now we're going to copy this and move it down to prep move 4 and do the exact reverse of this. Whoops, wrong key. So movement component B wants to sprint equals B saved wants to sprint. Okay, next up, can combine with. So really what we're going to be doing, the only check is going to be whether or not the new move is equal to our B wants to sprint, or sorry, B saved wants to sprint. So if we look through the can combine with parent call, you can see it's basically just a bunch of different conditions based upon what they want to have set. So that's, again, the only thing we're going to bother with. So if B saved wants to sprint does not equal the new move of saved wants to sprint, in which case we will return false. So to do that, we have to go from f saved moved pointer to our, well, f sprint saved move. So to do that, we want to do a cast. So we can just do a C style cast. So f sprint saved moved character as a pointer, new move, and we want to get b saved, let's see, oops, I goofed a little bit, b saved wants to sprint, and I realized my goof here. Okay, so let's see, where am I goofing at here? Yeah, that should be fine. So, you should have no problem here. Okay, I guess it's been long enough where I forgot how to do a C-style cast. But simply enough. Okay, so now that's basically set up. Now the only thing we have to do now is, should just be, yep, we're done there. So yeah, allocate new move. So yeah, that's all the parent goal is doing. So basically we have to construct the f saved move pointer for our own class here. So f sprint saved move character. So to do that, we construct a f saved move pointer from our f say sprint save move character. Simple as that. Okay, so now let's go ahead and compile and just see where we're at. Make sure I didn't miss anything stupid. Okay, so we have some complaints, and that would be line 44. So right here, however, it is not actually that line throwing the error. So the issue is actually line 43. So here you can see where I created super. I made a goof, and basically what it's doing is when we call super right here, click on the bar, it is calling itself, so to speak. Hence the name delegating constructor calls itself. So that's due to the naming. We're not actually calling anything in response to the parent. So we're going to do f network prediction data client character and replace it over top of f sprint network prediction data client character. So that way we should be calling the parent instead. So now let's go ahead and build, and we should be good to go. Okay, seems like we're okay. We have our function there. And what I want to do is I want to print out to make sure everything's okay, but we'll actually just go ahead and set it up in Blueprint really fast, because there is a function that we have to call, which is going to be our get max movement speed or max walk speed, whatever it is. And that's actually going to be where we set up our sprinting. So I'll see you here in a second. Okay, so back here in Blueprint, what we want to do is basically stop all this. So I want to drag it out of the way and delete our two calls to the sprint event. Instead, what we want to do is we want to get our character movement component, and we want to cast it, which is going to be unsuccessful first, to our sprint. Here it is, sprint character movement component. So we perform that cast, and here we call set sprinting. So I'm going to pass in true, copy this, paste it down below, and plug it into released. So when we release, what we want to do is we want to set sprinting to false. So press left shift, we sprint. Release it, we stop sprinting. Simple as that. However, this is never going to succeed, because if we hover over the character movement component, you can see here that it is showing the character movement component is currently character movement component. It's not our sprint character movement component. So we have to fix that by going to our character. So let's go ahead and close this down. Head over to our character.h and .cpp. And let's head to the constructor right here. So here we want to go ahead and we have to actually set it up so the constructor takes in the object initializer. So we're going to do a constant f object initializer, object initializer. Copy that, go to our .cpp, paste it in, And here we want to call super. And here's where we're going to do basically set the character movement component inside of it by name. So one thing we also want to make sure we do is include our new character movement component too. So I'm going to go ahead and move those down. And first off, let's go ahead and include, I said first off, the, sprint character movement component .h. So that way we know we're going to be fine there. Okay, now we go, oops, made a goof. Super, here we want to call set, or is it as the object initializer, set default subobject class, and here we're going to do the movement component. So u sprint character movement component from a character, character movement component name. So that should give us the, that should allow us to override the character movement component with the class that we pass in here, or better yet, the type that we pass in here. So let's go ahead and give this a try. Okay, back in our character, if we hover over our character movement component, you can see it now says sprint character movement component at the end. So now, if I go ahead and print out a string after I press left shift, so I'll go ahead and I'll leave it there. Let's go ahead and see. So I press left shift, hello. And every time I press it, it prints one out. So we know that the calls are successful. So now let's go ahead and set it up so it has some functionality. So we should be having everything should be replicated. Now we just have to modify it so it actually does something. So here's where we're going to make use of B wants to sprint. So we're going to override, let's see, is get max speed? I thought it was get max walk speed. No, I guess it's get max speed. So do that, create the definition, and let's look at get max speed. So here you can see it's based on whatever movement modes we're in. It returns the corresponding one. So for example, if we are crouching, then we return the max walk speed crouched. Otherwise, we return the normal max walk speed. If we're falling, max walk speed, swimming, swim speed, flying, fly speed, so on, so on. So in our case, we're just going to use a static variable, and then we're going to set it up as a blueprint new property just to make sure it actually works. So we're going to go ahead and get the super value. Don't know why I backspaced out of that, but float speed equals get max speed. And then we simply return speed. And I'm going to make mine very simple. So if B wants to sprint, we're going to take our speed and just simply multiply it. So speed equals speed, or better yet, times equals 2. So this should double our current speed. So I'm not sure if the new UE5 preview allows for live coding of the header yet. I'm going to go ahead and compile and relaunch, and with any luck, this will actually work. Okay, we got our blueprint character set up. Let's go ahead and hit play, and I sprint and release, sprint and release. So sprinting seems to be working. Now let's do the old test before, which was the packet lag at 300. So set that, sprint release, and I'm constantly spamming it, as you can see, like so. So I'm starting stopping, and everything is actually quite smooth. There's no jitter like we had before, and everything seems okay. So let's bump this up to something stupid high, like, let's go to 600. Sprint. And everything is smooth. There's no rubber banding or any issues like that. Now, let's compare that with the old version. So what I'm going to do here is call sprint. Going to uncheck that. So we're going to sprint the old way that we had it set up at the initial video, or the first video, which is the default way that pretty much everywhere everyone shows you, including myself in the previous ways, or in the old videos. So let's see the result of that once I actually load in, thanks to high ping, and I sprint. Or maybe it reset itself. Put the packet lag back up. Now, why is it not doing that this time? I am in a client, right? Yep, set as client. Let's see, none of that should be called. Still replicated. All right, fixed it. I don't know why, but anyways, I got it set up to where it is going back the normal path, but there we go. We're starting to see all that rubber banding, just like so. And as you can tell, it's pretty nasty. And you can see all the correction to try to correct the location, like so. So I'm going to revert it right back and make sure that everything is good to go like normal. Again, still playing as client. And now everything is back to being smooth as butter. So we don't get any of the jitter, any of the correction or anything like that. Everything is now nice and smooth. Okay, so that's really it. Now you are basically at liberty to create a custom sprint speed variable, which we will do in the next video, and that's going to wrap up the series. So very straightforward. It's not really the most difficult thing. It's just a lot of basically, I guess you could say, boilerplate, because that's a solid 90% of working in the character movement component. Once you get past that, you start implementing your own functionality, it gets a little bit easier and easier. And once you have one thing set up, you have a nice clear reference where you can go through and see everything that has been done, and you can do it yourself with other things. So that's going to wrap up this video. Like I said, in the next one, we're going to go through and we're going to set up a custom blueprint variable that we can alter to basically control our sprint speed. So I will see you then.